So let's start. Welcome to this session where we at Inmotion presenting the trends and challenges in moving from fossil to battery electric vehicles. We're going to talk about the trends and the power electronic applications. My name is Wennerblom, and today we also have Erik Norberg and John Söderberg with us to present. Let's move on. This presentation will start with the mega trends, and we will narrow it down to all the challenges that we have in the various areas. So let's kick off with the mega trends. As we know, we have a rapid urbanization going on, where cities are consuming most of the natural resources, and that actually accounts for 80% of the greenhouse gas emissions. These numbers are found from PwC and are also picked up by other institutes as well. The rapid urbanization actually has 1.5 million people are moving into cities each and every week. So this is a gigantic movement of people causing that cities needs to be very careful and conscious about the global gas emissions. And we know the next mega trend here is the scare climate change that is ongoing and the climate crisis. But we also have resource scarcity. So this is, of course, a big problem. And we can see that there will be a lot of more energy consumption required going forward. Not only is it food, water, but also energy. So bigger demands on electrification. This calls for actions where we need to be much more efficient in our usage of the electricity and the natural resources. The IPCC released a report yesterday, and we have big challenges in fighting to stay below the 2% or stay below the 2-degree target. So it is really important that we action that straight away. That was also picked up by Saul earlier on the presentations today, that we have 30 years now that we can really make a difference, and electrification is one way of making that difference. We can also see a shift in the global economy power, where countries like India and regions like Asia is picking up, and that changes the structure of what we have today, where we have Europe and the US being on the top three, but India will definitely pick up on that, and they'll plan to be or estimated to be in second place on GDP by 2050. It's not only that, but it's also the demographic and social changes where we have an aging population. So in 2015, you had 4 working persons on 1 pensioner and retired person. In 2050, that would be halved. So this also calls for actions in terms of our how we must learn and behave as well when it comes to the social structure. Continuous learning needs to be improved, because we need our fewer to support the retired people. But the big shift here that we're going to talk more about today is really the technological breakthroughs. The amount of data generated, as we can see here, from 2009 to 2020 is 44 times greater. It's also so that we see issues, not issues, but an increase in demand of data that is generated. And 90% of the data generated, it was generated in the last 2 years. So it's an enormous growth on that. And we also have more connected devices, demand more on-demand services straight away. That taps into the next slide, really, about the technical breakthroughs, the digital disruption. So we can see that we have more integrated use of AI in products. So the products are getting smarter, we're getting more optimized, and that is, of course, something that we put in our products as well. We can typically example is robotics, for instance. Electrification in the transport sector that Christer Thorén spoke about in the earlier presentation is also key to lower the carbon emissions on the planet. So that is now starting to gain momentum. It also opens up for autonomous vehicle and on-demand mobility. And in the high density cities, the on-demand mobility is predicted to take over, because in 2050 you may not even own a car in a city, but you will use the mobility services instead. All of this is, of course, connected. So the connectivity is really growing, and we see that in all types of products. This in return, you see the word cybersecurity, and security is something that is super important to keep the businesses running and make sure that everything is up to speed and deliver the services that is promised and requested by the customers. So the in-vehicle cybersecurity is a key thing, and John will talk about that a little bit later in the presentation. Moving forward, I mentioned the smarter electrical solutions. Here we have a few examples in the shift in transport and logistics. On the left side here, we have the pods. We have the heavy vehicle pod from Einride in Sweden. They developed this and have this in service since 2019 on test tracks, but it's still in real environment, not only tests. And that is enabled through, it's fully electric, so it's enabled through the electrification. Same with Amazon test they do for autonomous vehicles deliveries. Even more exciting is the flying drone that is developed and deployed in Dubai. I'm not sure if it's already in use, but it's something that is tested. And of course, again, Christer spoke about the shift and the possibilities and opportunities that we have with the electrical highways across not only Europe, but in other areas as well. So there's definitely a shift in that and going to more electrified solutions in transport and logistics. All of that is, the purpose is, of course, to counteract the climate crisis. And I just wanted to show this slide where you have the sustainability goals, the 17 sustainability goals. And at Inmotion, we work with them as well and have that as part of our delivery to customers. So, and the purpose here is really to make sure that we are getting on top of the situation on carbon dioxide and other areas that it's destroying the planet, basically. So if we see the next slide, we have an animation of the carbon dioxide, what happened globally since 2002. And we can see that the levels of carbon dioxide is growing throughout the years. It's getting constantly. And we all know what happens as a consequence of that with the weather storms, with the thunderstorms, with melting ices, and so on. And that in return is really driving the electrification. We really need to act on all of this. What we see is that we have countries that are acting on it, and they plead net zero emission pleads. In 2045, we have Sweden that is saying that we want to be net zero on our emissions. European Union is following after that in a few years after. But those are quite far away. It's 2045. What happens now is that already in 2030, the electrification takes place in the vehicle industry. It's an important part because we're removing the combustion engine and bans that. Norway is first out. They have the highest population of Tesla cars per capita in the world, and other countries as Netherlands, Sweden, Denmark, etc., are following that path as well. So it's very positive. It's starting to happen. It's really driving the shift towards electrification, which we are working in. I took two examples of showing what's happening on this. First example is what has been done, and this is to reflect a little bit of the past, where you have congestion charges. I think every city in the world basically has that nowadays, or largest city. But London implemented the ultra low emission zones as well, and that is for restricting further the vehicles going into that zone, and that is due to environmental aspects, of course. And we can expect zero emission zones, and not only expect, but there are declarations done on that. And this slide is from July 2021, where we can see that zero emission zones are to be implemented not only in China, but also in Rotterdam, and others are planning to go that way as well, which is very, very positive. And again, that connects back to what I said in the beginning, where you have the largest cities that are expanding, more people are coming into that. And it needs to be done in such way, that expansion, that it allows to be climate neutral eventually. I took the example here of number of vehicles. So this is from the IEA report. We can see that we're talking here about since 2012, there's been a great expansion of number of vehicles. In the light blue here, we have the light duty vehicles. We can see that we're just about 10 million units. The smaller parts here on top, I expanded that and removed what we have on the light passenger vehicles, having only light commercial buses and trucks. And we can see here that the bus market, that is really a market that's done electrification, but not it's not at all at the scale of pass cars, which is 10 times bigger. But the trucks, they are really low, and that is starting now. That is really starting now. And of course, there have been legislative measures put in place to facilitate that, but also the drive from the UN and from the climate crisis as well. So how does it affect us? It affects us also in the way of circular economy, where you used to have the raw material and straight line to the customer and consumer, and then you didn't do anything more with that material. Now that has changed. So now and the future, we talk about taking the raw material to the consumer, customers and consumers, and then to reuse it. And our customers in the truck and bus industry are very see this as a very important item, and a trend that we see that they're asking for the R9 framework, where you basically say that from R9 is to recover the material or recycle, to reduce or even eliminate the material at all. And this is also an example of reuse is the EU directive that is coming when it comes to increase the battery life cycle approach. So demanding more recyclability of batteries. That is really important. So all in all, I'm going to do this last slide before handing over to Erik. The mega trends that we see impacting Inmotion and our industry is that we see definitely a surge for electrification solutions. That is no question about that. And that Saul mentioned that as well, electrifying US and the world. That it's a big shift, more solutions. What is also critical is the time to market. It's something that we need to do now. We can't wait. It needs to be done now. Later is not an option. It needs to be done now. So the products, the inverters, the power electronics that we have, calls for a wider product range and new applications. Drone was one of the applications that could be an opportunity. Also, more flexible solutions with even smarter software to scale it faster. That is important. But also the environmental aspects, where the future product must meet the circular economy. So you need to disassemble, take care of all the content, and especially the rare earth metals. That is critical and crucial. Again, security, the cyber security in every application is key as well. So we must not forget that part. And last part here is the sustainability impact is to be minimized. It's not only the carbon footprint, but also the metal content, the content of the product, and the transportation. And the transportations connect to the localized manufacturing and sourcing. So long logistic chains to provide material to a factory or a plant far away it's not viable in the long run. It needs to be more localized, make sure that you have the sourcing and the components and the infrastructure set up in that region where you operate and where you have the customer and where you have the demands for it. So with that, I will hand over to Erik that will start presenting the current Inmotion products and applications. Thank you.
Yes, thank you, Martin. So my name is Erik Norberg. I'm product manager here at Inmotion in Stockholm, Sweden. I will start to discuss a little bit about our current products and applications where we work. At Inmotion, we currently deliver both inverters and DC converters. These applications can be split up in two different voltage ranges, where we have low voltage products and high voltage products. With low voltage, we define them as system voltage up to approximately 96 volts. And the high voltage products are in the range from 300 up to 800 volts. So going into different application areas, we can take this step by step. And one of our major areas is material handling. In this case, it's a forklift. For this application, we deliver inverters for traction and hydraulic pumps. The second area worth mentioning is construction equipment. In this area, the electrification has recently started, and depending on machine size and power needs, these products use either high voltage or low voltage products. We also have a third major area, and this is container handling and port equipment. This application has started to be electrified mainly due to emission regulations in ports, I should say. These products is mainly high voltage due to the heavy loads handled. At Inmotion, we also deliver products for truck and bus. In this application, we have both DC-DC converters and traction inverters today. We deliver to a couple of big OEMs in the world. And connected to the electrification of trucks, there is a market for auxiliary products. And these are products for bodywork, could be concrete mixers or cranes. And the typical application is refuse trucks, concrete trucks. And also worth mentioning is the agriculture and mining equipment. This area has not yet taken off in electrification. We see some trends in agriculture where we are building prototypes today, and we hope it will take off shortly. Next, we would like to go into the shift in technology, and I will try to explain what electrification means. And we can start with a generic truck. This is a ICE system. This is internal combustion engine in this case. These systems are built around diesel engine, connected to gearbox driving the vehicle. All the smaller loads are typically belt-driven. We have power takeouts connected to gearbox or either directly to the diesel engine. So this is a conventional vehicle. What it takes to electrify this is to start changing components. And typically, the first thing is, of course, the diesel engine will be removed. The major gearbox is also removed and replaced with electric machines connected to a 1 or 2 stage gearbox connected to the driving wheels. The power is taken from the inverters. With this setup, also the reverse gear is removed, of course, and is replaced by reversing the electrical machines. All these smaller loads as fans, compressors, coolant pumps, all of this has been electrified and can now be placed virtually anywhere in the vehicle. On the diesel machine, there is typically an alternator charging batteries. This is replaced by a DC-DC converter in these systems, charging the low voltage batteries. Then, to charge the high voltage batteries in a vehicle like this, a onboard charger is added to allow charging at any location. And to connect all this high voltage equipment, the system also contains a junction box, and anywhere in the vehicle where you have space left, you will add a high voltage battery. In this picture, all the darker blue components are components that Inmotion in Stockholm can deliver. So we can move on, and there are, of course, alternative ways to build this vehicle. One way is to place the electric machines directly on the driven wheels. Then you have 2 electric machines and 2 inverters in the system. This is a very popular setup in, for instance, city buses to allow low floor solutions. And with this, we suddenly have converted our diesel machine or diesel vehicle to an electrical vehicle. But we are not ready yet. So the next step where we are seeing trends today is the fact that these vehicles now start to be assembled on the same assembly lines as conventional diesel machines or vehicles, which means that the assembly time for an electrical vehicle will have to be the same as for a conventional machine. And one trend we see is merging components into pre-assembled packages. In this picture, you can see that the inverter, the gearbox, and electric machine is assembled together as one powertrain, which is then assembled as one package. Also, going to the next picture, all these smaller components as DC-DC converters, chargers, compressors are pre-assembled in one package. And all of this is then assembled in the vehicle plant at the same place where today the diesel engine is integrated to the chassis. So as we discussed on the previous slide, now we're going into power density in power electronics. As I mentioned, as the vehicles are assembled or pre-assembled, all the components will have to fit in smaller and smaller places. This calls for higher power density in power electronics. And this is a study where we can look at and compare the Inmotion DC-DC converter. The task of the DC-DC converter is basically to charge the low voltage batteries, taking energy from the high voltage batteries in the vehicle. And we can compare in these slides the Inmotion generation 1 with the current product, which is the generation 2. And we can also look at the future where we see where we'll have to go. And we can start to look at the power. In generation 1 and generation 2, our products delivered 7.5 kilowatts at the 28 volt output. What we see in the future is products for at least 10 kilowatts per unit. At the same time, we can also look at the volume of our products. We can see that we have started at 25 liters. The second generation today is 12 liters, and the future will be less than 10 liters per unit. With this, we can, of course, calculate the power density if we would like to. You can see that for each generation, the density or power per liter is increasing. In the future, we will be at least 1 kilowatt per liter. Then there is one last factor to mention, and that's about efficiency, where higher efficiency enables longer range for a vehicle, i.e. less losses in the system, also means that we have less required cooling. And less cooling also means that we can build smaller products. You can see that now there, the first generation, we were about 90% efficiency on the DC-DC converter. The second generation today is 94%. And we can also see that in the future, we see that the requirements for these kind of products will have efficiency requirements of about 97% to meet our customers' requirements. And with that, I'm going to hand this over to John, who will continue with the section about, there we go.
Yeah, thank you. My name is John Söderberg, and I am also working as a product manager at Inmotion, Stockholm. I'm going to talk about some other trends within the technical field. So, voltage levels. As the power levels of electric vehicles go up, there is a trend of moving towards higher system voltages. So, golf carts, forklift trucks, and other light or low-speed electrical vehicles usually have a better voltage of 24 to 80 volts. Electric passenger cars are often in the 300 volt range, and commercial vehicles have been in the 600 volt range for some time. But heavy commercial vehicles and also high-end passenger cars, they are moving towards 850 volts, and we expect even higher voltages to come here. Material handling applications are also going towards 120 and beyond for heavier vehicles. And the reason why the voltage levels are going up is to lower the amperage in the wires and in the power electronics, basically. The wire size is dimensioned for the current, not the power. So a higher voltage will allow for either faster charging and discharging without increasing the wire size, or to be able to use a smaller dimension wire for the same performance. Smaller wires mean less copper and easier installation in the vehicle. But increased voltage does, however, lead to safety concerns. So depending on the application, it might require risk mitigation, such as operator training, touch protection, isolation monitoring, and so on. And as a consequence of these higher voltage levels, there is a standardization initiative going on for a megawatt charging system, MCS, that can go all the way up to 1250 volt and 3000 amps DC. And for comparison, the current CCS charging system only go up to 800 today. So the goal here is to reduce the charging time for heavy commercial vehicles, but the system can also be used for passenger cars, ferries, planes, and other types of vehicles. And Inmotion is involved in these discussions in the Swedish ISO and IEC committees. So another thing that is important when moving from ICE to BEV is the effect on the vehicle's safety functions. So the safety goals of a vehicle will often remain similar, but the implementation can differ in many ways, and that's important to keep in mind. One example is if you change from hydraulic to electric actuators for a machine function, where previously the safe state would be to disable hydraulic valves, that's might no longer be possible. So this must be replaced with a safe state for the inverter, for example, instead. And for an electric drivetrain, there are also new failure modes to take into consideration. For example, if a permanent magnet motor is used, one must carefully think through the system design and the safe state. If the safe state is to disable the inverter, then that can at high speed cause the PM motor to induce a dangerously high voltage back to the battery of the vehicle. So in those systems, you must use an inverter with the capability of short-circuiting the motor phases to avoid such dangerous overvoltage situations. And the safety must be considered from the beginning of the project, and the safety requirements are among the most important factors when specifying or selecting your power electronic components. Recently, some actors have also discussed including electrical safety, such as shock, fire hazard, or over voltage within the functional safety scope. That is not directly required by the standards, but it can help you to mitigate some system level risks in your vehicle. Yeah, that's functional safety. Another big focus area within the automotive industry right now is the new UN regulation R155 and R156 for automotive cybersecurity and software updates. That must be fulfilled by 2024 by the latest for existing vehicle models, and already this year for new type approved vehicles. And connected cars filled with technology, they are attractive targets for hackers. So improved security is very important. But the implementation time for this standard is very limited. And there's right now a very high demand for these competences. So this is a challenge within the industry right now. There is a new standard developed, ISO 21434, that is supposed to meet these regulations so that you will pass the tests for that. But right now, these regulations cover only road vehicles, but we expect that other industries such as construction equipment and agriculture will follow, because this is an increasingly important issue. this standard then, ISO 21434, it covers the whole life cycle of a product or a vehicle. So the standard requires OEMs and suppliers to set up a cybersecurity management system, CSMS, with processes to cover the entire life cycle of a component or a vehicle, including responsibility for sub-suppliers, all the way from the concept phase to the decommissioning of the part. So threat analysis and risk assessment, or TARA, that's a very important document within cybersecurity. That's a central part of this standard. So it's quite similar to what you do in functional safety, where you have a HARA. And it's a live document that follows the component or the entire system through the life cycle from the concept to end of life, and continuously being updated when new risks or vulnerabilities are found. So different components in a vehicle will have to implement different levels of protection depending on the risk that is associated with the component. And that is shown by the TARA. For example, a traction inverter is more security critical than a PTO inverter, for example, due to the potential damage that can be caused if the component were to be hacked. And a supplier to an OEM is responsible for continuous cybersecurity maintenance and monitoring and patching of security vulnerabilities during the lifetime of a product. So this is not just during the development phase of a new component for a vehicle. This goes on through the entire lifetime of the vehicle until it's taken out of production. Yeah. Then another trend within electrification is to replace hydraulics with electric actuators. And that happens in many types of machines right now. It cannot be done for all types of axles right now due to technical limitations, but where it can be done, it provides a lot of benefits. One interesting example is a professional golf course lawnmower, where conventionally they are hydraulic driven, but the conversion to electric traction and padding can actually be justified on its own by the fact that the risk of an oil spill on a golf green is mitigated. And in applications where we have been involved to do this, we have seen also a significant improvement in machine performance as an added bonus. Not only does it become silent and limit the risk of oil spill. Okay, so some conclusions from this session. The big trends we are seeing is that power density of power electronics is increasing. Voltage levels are going up. Components, they are integrated into systems, where the first step is pre-assembly. Manufacturing and sourcing are localized. And the time to market is significantly shorter. And the big challenge is then material selections and designs must be addressed to support the circular economy. We see need for increased security in all components and systems. And competence in new ways of building vehicles must be built up within the companies. So that was our presentation. Should we open up for questions?
Thank you for that. We have some questions. There was a question on the voltage levels.
Yes, for construction equipment specifically. Yeah, we can say that in construction equipment, we see two voltage ranges today. In the low voltage machines, lower power or lighter vehicles, there is typically 48 volt DC on the system side. And for heavier machines, the voltage levels are going up to around 750 volt DC.
Thank you, Erik, for that. And there was also, we can mention that there is a separate session also during this conference, touching on the 26.2 part, the safety standard, and also the cybersecurity. That would be, I think that is tomorrow. Was that right?
I believe so.
Yeah. So that is for tomorrow. Maybe we have further questions. Any other questions from the floor? Okay. Thank you. Thank you. And we will stop this session now then, and next session starts at full hour, so 6 o'clock Central European time. Okay. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.